Hello, ladies and gentlemen. Today we're going to be taking a look at solving exponential equations. So this is finally, we're to the point where we're actually at that reason why we learned about logs, so that we can do some solving. We can isolate those variables to help figure out what x equals. For this, you're going to need your notes, a calculator, as well as something to write with. So to solve an exponential equation, to solve an equation that has a base and an exponent in there, you need to know your properties of exponents, and you also need to remember how to change things into log form. So please make sure you get this part into your notes. We're talking about 2 to the 4th equals 16. Remember with me, how do we turn that into log form? For that, we would write the word log. Think about what the base is. The base is a 2, so we'll write 2. Then 16 equals the 4 exponent. Remember, the exponent is always alone on the other side. He's always isolated. That's why we use logs. Now for the next one is e to the 5th equals 148.4. For this, we're going to write them in log form as well, but remember that logs with base e have their own type. They're the natural log. So what I would write is natural log, and if you want to, you can write the little base of e down here. You don't have to, but you can. And then 148.4, and then equals 5. Again, 5, 4, notice that the exponent is by itself. And you also should remember, as we get into this, how to use the change of base formula. So how to evaluate things written in log form. So like log 4, 12. How do we go ahead and evaluate that? For that, we're going to use our calculator, and we're going to type in the log of 12 divided by the log of 4. And that'll give us our answer. So all of these skills come into play as we go forward in trying to solve exponential equations. So the first thing I need to get into a little bit is about the different types of exponential equations we're going to be looking at. So write these two examples in your notes. We're talking about two different types of equations. Ones where there are exponents on both sides. Notice this first example here. Exponent, exponent. They're on both sides of the equal sign right here. And then there are also equations where you have exponents, but it's only on one side, like this one right here. An exponent on one side versus an exponent on two sides. The way we solve each of these is a little bit different. When you have exponents on two sides, you do something different than if you have exponents on one side. So let's start with exponents on both sides. Write this heading into your notes. When you have exponents on both sides, we need to think about making things equal. This first example here is really simple. 3 to the x power equals 3 to the 5th. So think with me, what number, when I plug it in right here where that x is going to equal 3 to the 5th over there? Well, notice that the bases are the same. This is saying 3 to what power equals 3 to the 5th power? You should be thinking, the x has to be a 5? Exactly, because I need both sides to be equal. That problem is pretty easy because the bases on both of these are the same. Then we only need to look at what's happening in the exponent and make sure that the exponents are equal. We're going to use that same strategy right here on this next one. We're going to think about making things equal. So the next problem is 9 to the 2x equals 27 to the x minus 1. Notice how the bases are different here. This is a 9, this is a 27. We want to make the bases become the same. So 9 and 27, we all need to think about what common base would they have. If you're thinking about 9 and thinking about 27, both of those can be written as 3 to a certain power. So if I change 9, it's 3 squared. That's still 9. That's still 9, and now I'm going to put that 2x power back on it. 27, if I rewrite him as a base of 3, it's 3 to the 3rd. And then I'm going to keep that x minus 1 power on him. Notice that I still have 9 in here and 27. I've just rewritten them in a strategic sort of way so that we can solve for the exponents. Now look up here, exponent, exponent. Now that the bases are the same, we can work on making the exponents equal. So when you have a 2x power onto another 2 power, we multiply those exponents. It becomes 4x. So we have 3 to the 4x equals 3, and now we're going to do that same thing here, multiply those exponents. X minus 1 times 3 means I have to take the 3 times both the x and the negative 1. and it becomes that power. So now I focus my attention not on the bases because they're the same, but now I worry about the exponents. When does 4x equal 3x minus 3? And then we solve, we minus the 3x, minus 3x, and we get x to equal negative 3. Woo! X is negative 3. So we thought about making both things equal, and then that allowed us to just isolate the exponents and just solve them and not worry about the basis. Now let's look at the other situation that could happen where you have exponent just on one side. For this, we need to isolate the base, but now we have to change it into log form, okay? So when we have exponent on one side, there's only an exponent up on the 2, no other exponents. I need to isolate the base and change it into log form. So I need to do as much as I can until I get stuck and then turn it into logs. So I'm going to add the 1 here. 2 to the x power equals 7. And now that I have nothing else that I can undo or use to isolate that x, now I rewrite them in log form. So this becomes log base 2 of the 7 equals x. Notice that the exponent is all by himself. And now here's where you go to your calculator. How do you get this from your calculator? You type in the log of 7 divided by the log of 2. That's the change of base formula. So you'll have to go to your calculator and type in log of 7 divided by log of 2. And you get roughly 2.8. So x equals 2.8. Let's do another example like this. So let's work to isolate the x's. Notice that there's a 4 in front of the e. I'm going to divide that off so that I have e to the 2x power equals 5/4. You can leave it as 5/4. You can make it, whatever decimal if you want to. It's fine either way. 5 divided by 4, if you choose decimal, is 1.25. And then once I've done everything that I can do, now it's time to write it into log form. For this one, writing into log form, we're going to use an ln because this has a base of e. So the natural log, which is the little base of e, 1.25 equals 2x. Now this I can get from my calculator. The natural log of 1.25 is 0.223, and that equals 2x. Notice that the x isn't yet alone. We'll divide by 2, divide by 2. X equals 0.11 approximately, okay? So we're working to get x alone. We're doing as much as we can until we have to write it into log form. One more like this. We'll subtract 1, 3 e to the x power equals 84. I can move that 3 away, division, okay, undo. 84 divided by 3 is 28, so I'd have e to the x power equals 28. And now that I've done everything I can, now I log it. I write it in log form. The natural log, which has a base of e, of 28 equals x. So I'm going to go to my calculator, ln 28. The ln button is what you use, is 3.33. And that equals x. Done. Thank you very much, ladies and gentlemen, for taking lovely notes.